Thanks for the kind introduction. So I have the pleasure and honor today to talk about AI-powered prediction markets and give a small tutorial on machine-guided incentives. So first of all, before I start with that, as a hacker, you can always follow and you should download the code which I'm going to present if you have like time left over. That's definitely some cool boiler code you can use to design your own simple prediction market. So let me quickly go to that website. Oh, wrong link. Yes, anyway, here, github.com/DavidDow prediction market tutorial. Yeah. So let me start with a crazy thought I want to give you guys, like the motivation behind my research and the idea behind Gainforest and all the things I'm actually pursuing as a PhD student, which is like, if you think about blockchain, besides all the hype and the craze about the value of the Bitcoin rising and falling, and AI, what kind of problem would we like to have solved in our current society and world? And I feel like, I was thinking about it a long time, and one of the things I feel like what blockchain brings us new is incentives. Let me elaborate that a little bit. So self-interest is an integral part of human nature. Everyone is self-interested. People can pretend to be altruistic, but like, in the end, we are all interested in our own benefit. So can we rechannel that intrinsic need for self-interest into something useful, into something like socially good? Just to let you think about that. I mean, so much power would be rechanneled into, if you even follow, imagine you would follow the best thing possible for yourself, and that best thing would also benefit society at itself. That would be the optimal thing. You would basically do good stuff, sustainable solutions without even thinking about it. But designing those incentives is really, really hard. Nobel Prizes were given out for market mechanics and designs, right? So can we maybe, going back to the time we are living, the information theory time, design a machine that maybe takes this incentivization design for us? Can a machine guide us to be a good human? So like, this is a crazy idea I want to give you guys here in, and I think we can. So in my research, I'm basically trying to figure out, can a machine give us good incentives to be good people? I will elaborate that in a few threads, but like the two main questions we have to solve is, first of all, how can we trust the machine? Like, every time he tells us something, how can we trust that this is from the machine, from algorithms, and not from like the central server? And how can the machine then actually influence our behavior? How can it incentivize a right behavior? And those two things, trust and incentivization, is exactly the solution the blockchain can deliver to us. So this is the unique intersection I see for blockchain and AI. So in our lab, a DS3 lab in Systems Group Zurich, we tackle both questions. First, how can we trust the machine? Instead of having run the machine learning algorithm on one central server, we are trying to create a data and computation market where we decentralize computation. So there's I will tweet out the slides later, so no need for you guys to take pictures or so. But if you're interested in, we just submitted a paper for ICLR workshop where we elaborate on this idea of trusted computation. The second thing is, how can we incentivize human behavior using machine learning algorithms? And this is the thing I'm going to now spend most of the time talking about, which is Gainforest. Gainforest is basically a case study of how can we use smart, intelligent algorithms to design a market that help to do some sustainable benefit, in this case, protect the Amazon rainforest. So in Gainforest, this is my amazing team and me for the Hack for Climate, and this is literally the pitch we're giving you guys, which we won the Hack for Climate last year in Bonn. So in Gainforest, we try to tackle deforestation. If you think about it, deforestation is really, really bad, and it causes actually an immense part of the climate change. So people estimate that about 30% of all carbon emissions are coming actually from forests burning down. So this is immensely, immensely huge. The Amazon is good, so we want to protect that somehow, but we see that deforestation is actually happening in the Amazon. So there are facts from satellite images that shows you that given like images from 1985 and 2016, we have huge, immense losses in forest areas. And the number one cause, when we studied that and talked to UN ambassadors at the climate change hackathon, is actually not big companies who are cutting down forests, but really local subsistence farmers who really just care about their cattle and have some, they just want to basically make space for their cattle to eat and grow. So there's one simple solution which was proposed in a science studies many years ago, and they studied basically giving those local farmers in Uganda, I think, small financial incentives, and could measure that that would cut deforestation by half if they have like financial independence from cutting the forests. So the problem about that is if you give money to people, who do you give it to, right? Like there, especially in the remote Amazon rainforest, there's like claims of land ownership where we are not sure if he owns that land or this owns that land. So that is the big problem, and we have actually a very simple solution for that. So we say it doesn't matter who protects the forest, as long as someone protects the forest. So we allow everyone to be a stakeholder, putting money on a specific part of the Amazon rainforest and become a caretaker for that. So how does that work? We try to remove the human from the contract and basically designed a blockchain-based smart contract where we rechannel financial incentives. So you see on the one side up there's the donors and the caretakers. The donors and the caretakers, they put money on a grid space, like literally a game board of the forest. And satellite images will analyze the forest after week and after week and after week and see if there's still forest on it. If there's still forest on it, the winner who bet on the right parts of the forest will earn extra. And if the forest is gone, the losers will lose and redistribute the stakes. And we will analyze the data via satellite images using machine learning algorithm, which is here the oracle. So it is completely without human in the loop. So let's see how it works. We forest, we put some money in it, we measure after the time period, redistribute the stakes, and we use satellite images for that. There's actually 4 different kinds of satellite images, specially designed to monitor the Amazon rainforest, and all sponsored by the Brazilian government. And we use GLAD data for our experiments, for what I'm going to showcase for you. But one thing is still uncertain. So given that Oracle's machine learning algorithms can literally classify if there's forest or not, it's actually a pretty simple task. It's green or not green in a more detailed manner. We think that there's still one attack point which is very obvious, right? If you design some game like this, which is in a remote forest. If everything is a game board, you would basically just put money in the most remote location, right? Where you know no one can cut that because no one will ever be able to go there, right? So we need to have some kind of smart, some kind of a heat map distribution to determine which parts of the forest are actually from the highest risk, and which one are not, in order to prevent those attacks from those smart investors. So what we do is we used a neural network. Here, a very simple explanation of a neural network. I'm going to more detail later. And the neural network basically trains on 20 years of satellite images where we have the differences between forests or not forests, right? So this is what you see here basically on the right side is the dark map is a map of a specific part of the Amazon rainforest. The purple is the spread of deforestation basically given the very first image from 20 years ago to now over the period where is still forest, where not, and you can see how it's spreading. And our goal is basically to train a neural network to predict the spread of this forest because we think the spread of this forest is systematic. So we trained a convolutional adversarial neural network on 24 GPUs for many hours. And to our own surprise, this very simple approach of overlaying basically a picture and trying to do a video prediction, right? Like predicting from a given sequence of frames and pictures the next frame is actually really effective. And this is something we are still trying to figure out why that is the case. But as you can see here, there are very special structures when you cut the rainforest. And they are called fish bones, where you know, I mean, usually when you lose forests, it's not all the time from humans, right? Sometimes like a lightning bolt can hit the forest and large parts of it burn down. But those fishbone structures are definitely human, because if a human cuts the forest, he first cuts a very long strip and then cuts to the side in order to transport the wood in an efficient manner with their cars, right? And those results, we were able to figure out that without actually training for it, the neural network was able to discover those fishbone structures, which was really interesting. So let me show you some initial results. So left, so this side here, is actually the ground truth data, and the right is the predicted spread of deforestation from the neural network. You can see it is actually very, very similar, very close. And even if you look at the small fishbone structures here, you can see it learns that the spread is going a little bit outside like this. So it's good enough to intelligently distribute funds. But we also looked at fail cases where it gave us a high error rate. And you can see here, again, left, ground truth, and right is basically the prediction of the neural network. You can see that the neural network actually predicts this waveform spread outside, which is not realistic, which is not seen by the ground truth. But what we assume here is that the neural network just predicted probably like a future which hadn't happened yet. So for me, if I look at that result, it makes sense that if that is the spread of deforestation up to that point, it makes sense that it will spread out waveform-wise downwise. So this can be also used to basically have a much stronger restriction and regularization for the betting system, which we are going to implement. So what we did, to summarize in 2 sentences, we incentivized, so we built smart contracts to basically create a staking system that is transparent, to incentivize people, and which is without any humans in the loop. And we enabled that by using satellite imagery that we analyze for heat maps, basically like areas of risk where the forest is going to be cut down. So what's going to be next? We think this, so one of the easiest cases, of course, to improve the neural network, right? But I want to give you guys a bigger picture here. What's going to happen? Actually, what's really exciting here and what's interesting by connecting an AI agent to actual political and influential movements by having it in the blockchain acting with humans, right? Because the moment the neural network predicts, for example, that this forest is highly likely to be cut down, right? It will increase the stakes. So people will stake more in it and will try to protect it, right? So it is literally a self-defeating prophecy. So by predicting that part of the forest, that this forest will be cut down, it tries to protect this forest, and then it won't be cut down. So this will influence back. It's some kind of feedback loop for the neural network. And what happens here is actually, you can see the whole thing as a game. As a game between human agents who want to maximize the profit, and the neural network who wants to maybe minimize the overall deforestation area. And we all know how good AI are in games. So I think this is a really, really exciting area of research where we can maybe combine the neural network not only with how well it predicts the deforestation, but how well it predicts the overall minimization of the loss, basically solving the game and winning against humans. Maybe it can also predict some strategic heat maps in order to prevent the human to put money on their point. And also another thing which we are going to do next is one of the things which is really still trust issue based is that we only have 1 or 2 satellite systems, 4 as I mentioned here. So we are experimenting right now and talking with DJI about having a swarm of drones which have a much higher resolution, of course, to the forest, and basically we'll use that to act as a decentralized acting oracles around the forest. So if you guys want to try out Gainforest, it's gainforest.org. We also have a research group specifically designed at this really exciting intersection between AI and blockchain. You can visit the website at blockchainai.org. And we are looking for students, of course. Whenever you guys are crazy enough to work on those projects, please contact me. Yes. So, yeah, let's go to the practical part of it. I want to, because I'm actually, so my background is in AI. I worked in Silicon Valley for a year in self-driving cars, and I'm actually fairly new to blockchains. So what my task is, and what I see my task is to give you guys like the most benefit, is to give you guys a short tutorial about how this like magical neural network worked. I know some of you might have experience, some of you don't, but I think it's really exciting to think about the neural network as a kind of intrinsic function approximator. So let me show you a little demo. So this neural network, who of you guys have ever coded a neural network here? Half of the group, nice. Who knows who can do backpropagation by hand? Okay, so those experts, please fall asleep, work on the code. So I'm going to explain you in a very simple terms how this neural network, for the people who never worked with it and never seen it, actually works. So neural network is nothing more than glorified logistic regression with multiple layers, actually. It adds, so what the neural network was doing is it's trying to adjust a function. Let's see here this example where we have this data set and we want to split it. We basically give a training sample and the neural network will figure out weights for a function to split that data set in this space area. So the more complicated the data set gets, the harder it gets to basically classify the two kinds of classes because the model is not big enough to basically capture the possibility which it solves the best, right? So the capacity of the model is limited by what classes you want to solve. And you can easily add that. So by stacking layers on top, you exponentially increase the possibilities of models which can be used to classify that data set. So that is why you stack them. You also stack them with a nonlinear activation layer. And it's very simple. The reason is if you stack them just with linear activation layers, linear and linear and linear, if you do the matrix calculation, it's linear. So this nonlinearity layer in between each of those stacks actually allows you to learn complicated arbitrary functions. So in the neural network community, we mostly use ReLUs, rectified linear units, which is a very stupid function, actually. It's 0 and then linear. It's just this nick on the 0, which makes it nonlinear. So it's very, very stupid. Exactly, and we have different kinds of training and a lot of dark magic wisdom where we do this, like learning rate, where we basically every time the neural network predicts something wrong, it has to correct its step. And this learning rate basically tells you how much it should correct in an absolute value, and so on and so forth. So that is very simple feed-forward neural network. Nothing really exciting, but to give you a hint why we stack stuff. So what's exciting, though, is that if you do this only, this is exponentially big, right? So mostly, especially if you work, for example, with deforestation images, this is basically image data. So image data has the plus that it's actually spatially dependent. So like pixels around another pixel are mostly similar because of illumination and the way the physical world works. And we can leverage that by combining the neural networks, neurons in very interesting ways. So here, a small demo about something we call a convolutional neural network. So convolutional neural network basically takes the image itself as a tensor and classifies here stuff, which is definitely wrong. I am not wearing a suit or any bow tie. But you can see here what's happening is if you split up so it's basically also a deep neural network with different layers, but the layers are now 2D. And if you look at the 2D functions, what it learns some kernels where it can basically dissect the image in different kinds of channels, information channels, and further them down. And the further you go down, you see the information gets more dense until the very last conv layers. And from all those different kinds of extracted information, it does the final prediction. So it's pretty cool. And the cool thing about it is because back in the times when we first had neural networks and AI, we used symbolic stuff, right? And symbolic stuff, the problem with symbolic stuff is every time some coder did only a slight wrong assumption, the whole system breaks down. And like a little bit too. So it is much more robust to wrong assumptions, which we humans have more than enough. So given those activation layers, you don't only can classify, you can also do a lot of cool other stuff nowadays. For example, one of my favorite demos, for the people who haven't seen it yet, is Pix2Pix, where you basically generate new images based from drawn images. So here we have basically a drawn cat, and it will process into a real cat. So let's just clear that down and draw a new cat. I think it's great. Don't laugh at it. So no. So this is literally like, it is very, very similar to what I explained to you guys. It's using the convolutional filters to train on a different cost function. That's it. But just given the fact that this model does not only learn to classify stuff, but also the intrinsic features it learns inside is very useful for a lot of different stuff. And this is actually one of the things we leverage for the video prediction of the rainforest. For example, the moment they are able to classify those fishbone structures is because inside those hidden layers somewhere, they figured out fishbone, human. Yeah, something like this. It's pretty cool. Yeah, many more demos. Just play around with it, guys. It's fun. Okay, back to the actual code. So feel free to code with me. Otherwise, it's fine for me to just do stuff. So for this demo, I will use the parity blockchain. I downloaded it with the instructions in the GitHub repository. Feel free to just follow it. So now we have basically, I already prepared this DApp, decentralized application called Simple Prediction Market. First of all, if you do that, remember to not use the Ethereum blockchain right now, but sync it to your local development. Otherwise, you will either lose a lot of money or end up downloading huge chunks of data. So now we are on our own blockchain. We will see that because all the other dApps, which used to be on the Ethereum blockchain, are lost the picture, but our simple prediction market should still be fine. So what we are going to develop now in the last 25 minutes, 20 hopefully, so you guys have still Q&A session, is basically, we will have a picture, and we will simulate basically this kind of task I want to show you guys, like this machine-powered incentive. We have some kind of data. In this case, it's either a dog or a cat. We don't know. It's a random image generator. A neural network will then classify if that's a dog or a cat, and the smart contract where people bet on if it's cat or dog will basically give out the money to the right bet of the cat and the dog. So let's go through it. So right now nothing happens, of course, because the smart contract is not there yet. We will start with designing the smart contract. So let me just develop a new one. So here, can you guys see that? Is that big enough, or should I zoom in? Okay. So it's very simple, and please never use that in your contract because it's absolutely not safe. You will end up losing millions of dollars like Parity did, if someone gets the joke. Yeah. So the prediction market here, very simple. We have an ID which is chosen, which is either 0 or 1. We don't know yet because the data haven't arrived yet. And I can vote on 0 and 1, cat or dog. The moment I vote, I will send out an event such that I know the blockchain knows they voted. And the vote function is simply just 0, 1 paying some amount of money, some bet I want to put on it, right? And of course, you're not allowed to vote multiple times. It doesn't make sense. Just vote between cat or dog, and that's it. You put a fixed, we fix it for 100 finny, so like a fixed amount of coins we bet on a bet, and then it will be stored in like this very small array. It's a hash map between all the bets, which was done, who has voted, and who chose what, right? And then the moment the data comes in, you can, if you know you won, you can click on release and you will get back your money times 10. So in order to start that, we basically first deploy it let's give it like deep prediction market. It's created. It's that simple. And it's on my local blockchain. So you can see it here, seeing that this thing has now an address with the actual contract in it. Again, all the code is in the GitHub repository, in case you want to follow me. Now, of course, this thing needs some money. Let me be like one of the generous people here and spend some money on it. As you can see, I'm very rich. Please don't kill me. So, whatever. Oh, too much. So, send, confirm, done. So this contract now has, oh shit. Where's money? Huh. This is not good. Wait a second. Maybe someone hacked me. So I want to send it to this. So transaction will throw an exception. Okay, let's use the gigantic account. You will have that money too if you work on parity, but it's all fake. So you have to still study. Yeah. So, let me update it. So, let's try it again. Local development chain. Hope that the contracts are still there. Contracts still there, no Ethereum. Let me see. That should be fine. So, let me try to send one more time. Recipient address. This box. Look for an exception of current values. Oh. It's kind of strange. Okay, let me try to deploy again. So that worked. Now, send it. Okay, whatever, let's just continue and pretend it has money. Let's see how it works out. So, so I prepared a small dApp here in that sense. And the dApp is very simple. It basically is a React app, and the React app provides you with following functionality. First, it loads the prediction market contract. Then it looks out who voted already in order to visualize who voted and who didn't vote. And you're basically, every time you click on something, you're allowed to vote. So the problem here, why it's not working yet, is we are still missing the contract address and the abstraction binary interface, application binary interface JSON here. So we can easily get that from the data. So in order to initialize the JavaScript object of that contract, we need both the contract address and the ABI JSON. I can easily get it from here. So if you look at details, that is where you get the contract ABI. So you basically copy that. It's literally a JSON file. So, and then for the contract address, as you can see here, it's very simple. It's just this address. And copy it here. And now the JavaScript should be able to access the states written on the blockchain. So you can see it by literally checking back the application, and hopefully here you have it. Cat and dog, we can wait, and you see my current Ether balance, which somehow don't submit stuff. So if I click on it now, I basically do a bet of 100 Finney. You can see it here. And now it is valid. So this contract has 100 Finney in it, and I see that I voted for dog. I think this is going to be a dog, right? Let's say another account, so this J. Rausch voted here. So another account, DWDAO, says it's rather a cat. Confirms, and now I put here a cat in. And let's say Big Money Boy puts in a dog, right? So it's very, very intuitive. We don't know yet if it's a cat or dog, but the bet's on. And if you look at the, if you now go back and actually look at the contracts, you can see the contracts now have the money in, hopefully, because otherwise it won't work here. So 0.3 Finney. So it's probably not being able to pay out exactly the amount because it's 10 times the amount of what it is, but it would be able to pay it out. So what's now interesting is how can we release the funds? Where does the AI comes into this blockchain now? Now, the moment where every one of you guys waited for, right? I mean, blockchain stuff, I know, but David, tell me, how do I do this fancy neural network in this dApp? And it's actually very simple, thanks to Google. Basically, because this dApp is implemented as a React, we can also leverage different kinds of React libraries. And heads up for you guys, since last year and this year, there has been a really, really interesting search in how neural network libraries are evolving. You know TensorFlow, you know PyTorch, maybe the old guys know Fiano and NumPy. But nowadays, people are just doing JavaScript because it's fancy. So you actually have a JavaScript neural network. So you guys now ask me, but wouldn't that be super slow? A JavaScript neural network? Yes, if it runs on a CPU. But what this JavaScript neural network library is doing smartly, it's leveraging, it's basically requiring you to put in a hidden canvas in the HTML and then access the canvas, basically accessing WebGL in your GPU. So you're forcing, every time the user calls the app, the user secretly runs his GPU to run the neural network predictions, which is really smart. So it's very simple to activate. Instructions are all inside the GitHub repository, but what we're doing is this library, DeepLearn.js, we basically inherited from the DeepLearn.js NPM module some utilities, and then we download ImageNet pre-trained SqueezeNet as SqueezeNet. So now we have that, this application binary interface. So let's just create a new tag called derplearn, where the moment we click on it, it will reveal the image, classify the image as either cat or dog, and then sets that into the smart contract as the chosen number. Here, really interesting, so in the app, in our main app where we have the constructor, this is all that visualization stuff. This is the interesting part. We initialize our GPU capabilities by accessing this hidden canvas, which I stored before. So let me also show you that. It's worth to see. So there's this hidden canvas, right? It's not 0 pixel, you won't see it, but this is the access point to the GPU for the DeepLearn.js library. So I access it. I have the WebGL, and now I run GPU on it to create a new context. And then I create something called an n-dimensional array math on the GPU and initialize this creasenet with it. So for a small bonus for you guys, if you want to try out the code later, you can try to ignore all that stuff and just to initialize it on the CPU, and you will see how painfully slow it is. But by this, you will have inference within milliseconds. It's fascinating. It's fascinating that this is actually possible from someone who works on neural networks for a long time. So let me show you here the code. So here we activate this turbulent tag, and it's very simple. This random generator is basically revealing if it's a cat or a dog. You can see it here. It's literally number between 1 and 2. If it's 0, then we take the cat dog image and image. So we just take images here. I have no fixed hard coding of 0 and 1, give out the money. It is literally classification here right now. So, and then I load ImageNet pre-trained on my website. How cool is that? So I load the whole pre-trained ImageNet model on my website, and it does the inference part for me. It classifies literally an image tag. But before that, we have to do some preprocessing. And the preprocessing is really interesting. Because we're running it on the GPU, we have to do it async. So it's an async call. And because it's trained on ImageNet, it only takes 227 by 227. ImageNet veterans will know. Otherwise, we have some stride issues. So we have to resize the whole image into 277 by 277 pixels. And then we do the predict by converting the image tag into an n-dimensional array. Wait for the prediction to finish, get the top k classes, and then iterate over it and see what it's up to. So let me just show you the demo. Just let you log out the results before I actually resolve the whole thing. So let's go. Final, second last step today. So the bets are on. The console is here, and here will be the prediction. And now let's reveal the image. It's a Persian cat with 99.5% certainty. And somewhere here, it's a plastic bag. But let's do another try. Here we have Serbian husky with 20% accuracy, which is obviously wrong. It's a Dodge. But here Chihuahua, cardigan, muzzle, Eskimo dog. It gets that it's a dog, right? So now you can see it. The inference is super quick. It's crazy. Just try it out without the GPU, and you will see that you have to wait a minute or so until it works. So now the final part, we resolve the whole thing. See if we can get back the money. So of course we have to reload. So now, the moment it got the classification, it sets the chosen value. And because we're doing it in parity, I need to confirm it. But this will be probably confirmed in a safe spot, right? Not with my usual account, but with the owner account of this prediction market contract. And now it's done. Now I can basically resolve and get back my money. So let's see if that final part works. I doubt it, because I set the payback to be 10 times more than that. But we can still check. So if you look at the contracts here, derp market, you see the chosen has been set to a specific value, and which is the dog, right? Because we got the dog as the last part. And now I can execute the function get me back my money, release. And if I have successfully voted on a dog, which I did here in this part, I will get back enough money. It's even more than the contract can pay me, and that's why now I get the transaction gets closed. But you can see it works now here. So this is really interesting, and this is really cool, and I think this is something you guys should definitely check out, DeepLearn.js, parity, and the whole tool chain. Yeah, so just any questions?
So we have roughly 5 minutes for questions.
I was wondering, with Gain Forest, if I'm a caretaker for a particular region of the forest, and and I was a malicious actor,
Mm-hmm.
wouldn't I just attack other parts of the forest so you'd redistribute the wealth to my section of the forest so I get a higher payout?
Yes, that is so. It's wonderful to think about the possible incentives, assumption, how people would act with that, and we thought about that a lot. And this is definitely one of the many questions we get. And I think this is a valid attack. What I can see as a counterattack is by the neural network knowing that you're going to attack, maybe by learning your strategy, it will, knowing that you are an evil guy, maybe increase the possibility that it's getting cut down around your stuff more than everywhere else, which incentivizes other people to put their stake on it, which on the other hand might incentivize that there will be soldiers shooting at you, maybe like this. Yeah.
Would you actually run any simulations to simulate those kind of dynamics?
Oh, that's actually right now what we're trying to do. So we are figuring out, like we are talking with a lot of people, like especially the Red Plus project from the United Nations, to try to get their point of incentives. They studied that, right? They brought some really valuable points to us, and we are actually trying to aim for actual test pilot in a small region in the Amazon rainforest, hopefully with some funding soon. Sure.
Do you have a challenge for the hackathon?
My challenge is to think about including AI, because I think AI itself, sure, I sound like someone who is promoting max hype here, right? Use AI and use blockchain. But I think if you look through the hype and try to figure out the system itself, I mean, seriously, they are orthogonal technologies. They don't overlap with each other. A blockchain, like nowadays, if you do AI on the cloud in the internet, it's also not considered to be hyped anymore, right? But like back in the days, maybe it was. So both systems have like their use cases, and combined they're super useful. And I think like if you think maybe about decentralized oracles, the way how can we ensure that data which is analyzed is also trusted because it's becoming outside the blockchain, and maybe using that, some kind of a local sensor network instead of satellite images. We use satellite images for forest detection, but maybe one can just use IoT sensors in some small regions like in the ocean to measure the pollution. That would be also really interesting, and maybe we can think about designing games in that area. So if you guys are interested in that project, you win the hackathon, and come to me and I offer you master thesis.
No more questions, comments? Well, in that case,
Thanks
thanks a lot, David, for coming.
Wonderful speaking.